Good morning one and all. Welcome to the session 5 on system software. The subject code it is 18MCA34. Today just I am going to discussing with chapter 2 assemblers, that is the introduction to assemblers. So assembler, first we should know what is assembler. What is an assembler? Assembler is nothing but is one kind of system software which is used to convert the source code to machine code, or machine code is also called as native code, which is used to convert the machine code to native code, source code to machine code or some kind of native code. So here whenever the user has created different kinds of program, it undergoes different kinds of phases of system software. First is it has to be compiled. So once the compilation has to be done, so means just we have to debug if any errors are there. So just we have to debug the errors. If no errors are there, the program is going to be converted. The source program, if all the errors are cleared, so the source program is going to be converted into object file. The object file which is going to be created by an assembler. So once the object file is being created, means it is ready to loaded into the primary memory. It is going to be done by the loader. So that is the executable code. So that executable code must be loaded into the primary memory by the loader. So after executing that program, the file, so it is going to be saved in the form of .exe file or .dll. It is depending on what programming language which we are using. So here, so the source code, so just we are giving the source code as an input to the assembler. The source code is an input to the assembler. So the assembler is going to process that source code. So then it is going to generate the object file. So while generating an object code, first it has to generate the object code for each and every instruction. After combining such kind of object code of all the instructions, then it is going to forming a single file that is called as object file. So the assembler is going to generate the object code or object file for the same source code. So once the object code is been ready, so then suppose some of the predefined routines, it is already there, that is the pre-process, that routine must be linked to the same program, or some other subroutines must be linked that one. So for linking process, it is using the linkers. The object code will be the input to the linkers to link whatever the routines or whatever the what routines must be linked to that particular file. So once that linker is going to, then the linker is going to generate the executable. It is going to generate the executable code is ready to load into the primary memory. So that is going to be done by the loader. So these are the different kinds of phases which the main source code which undergoes. That the source code must be input to the assembler. Assembler is going to generate the object code. Object code is going to be input to the linker. Linker is nothing but it is going to link whatever the subroutines and whatever the library routines must be linked to that particular program. So then it is going to forming that executable code. So once the executable code is ready, so then it will be the input to the loader. Loader is going to load that particular program into the primary memory for its execution. So here the source code, object file and the executable file. So there are three files which we can see, right. So first here after this just we are going to discussing about what is the main task of an assembler. So in this case when we are writing some kind of higher level languages, so the compiler, whatever the higher level language compilers are there, first it is going to generate the intermediate code, that intermediate language or intermediate code. So that intermediate code, it is in the form of assembly code, assembly level language code. Thus that assembly level language code, it is going to be converted into object code by an assembler. So this is how actually the program is going to be executed, is going to be undergo different kinds of processes. So first in this session just we are going to discussing about what is the main task of an assembler. Let me take a simple example program. For that just I am going to explaining step by step how actually the assembler is going to generate what that assembly code. So here so first just I want to discuss with the main function of an assembler. So before going to that one, so just I want to take a simple program here, how we can write the assembly level language program. So in the last class only just I have taken a simple example an SIC for copying the string from one string to the string value from one string to another string. So I will take the same program here. Just I will take the same program, that is the SIC program. So just I already explained, directly just I am going to write that SIC program here. So in some more example just I will take SIC XC. So load accumulator with the value which is present in memory location 0. So here it is having a loop. So just I am giving the loop name as move ch here. So first we are loading the character from the memory location string 1 at the index register value x. So then store character, the same character to the string 2 with the same index value. So after that index value must be incremented by 1 and it has to be compared with the length of the string. So here the length of the string it is 11. So just I am taking, so here the memory name for that integer memory location it is 11, and after that I want to, after that it is going to test the conditional code flag bit whether it is less than, greater than or equal. If it is less than, yes of course to move the remaining strings it has to move to the same instruction for reading the next, for copying the next value. So for that just have to mention this label name here, right. So this is the looping name, and these are the variables what I am using in that program. So that variables must be what initialized, must be defined in that program. So for that string 1 and string 2 it is nothing but is a character array, we can say string 1 and string 2 is a character string of 11, just it is having 11 different characters. So for defining that variables, yes of course, so whatever the program just we have written, this is having different kinds of fields. So this is the label field, so this is mnemonic field, and this is called as symbolic field. So the mnemonic field is nothing but is an operator field, symbolic field is nothing but it is a operands field. So the operand it might be single operands, 2 operands, maximum 3 operands will be there. So here after that just we have to define all the variables what we are using in this function, in this program, right. So first 0 is nothing but, so just I will write a memory structure here. So here 0 is a memory name, so it is having an integer value 0, and 11 is another memory name, 11 it is having the integer value 1. So then string 1, so it is predefined string, so it is having 11 different characters. So then the string 2 is there, so it is having, it is reserve space of 11 bytes. So again 11 is there, so 11 is a memory name which is having the integer value 11. So this is the memory structure for this program, right. So here means we have to define these variables what we are using in that program. 0 is nothing but it is having an integer value. So here, so just we are using an assembler directive, it is word. So that is the, for defining the type of an integer here. For the type of an integer we are using this. So after that, so what value which is having 0? What value which is having 0? So the next one is, what is the next variable? That is the string 1. The string 1, it is the character string. So character just we are going to defining by using assembler directives, that is byte. So means what character string it is having, just I am taking the string name, it is test string. So just you can take any name for that one. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters including space. So that 11 what the string length is 11. So the next another variable we are using string 2, we are reserving, it is a reserve byte How many bytes we need to reserve? Means I need to copy that entire string to the string 2. How many bytes which is required? 11 bytes. So after that string 2, 11 bytes, just we need to what? Reserve. After that one more character, it is 11. 11, what is the type? It is an integer type. What the assembler directive which we are using? Word. What is the value? Which is having 11. So means we have to compare the value every time, index value with the length of the string. What is the length of the string? It is 11. So what is the number of reserved bytes for the second string? It is 11. That's it. So this is how actually we can write that program. So this is the source code which has been written by the user. So I am the user, just I have written this code. So whatever the code just I have written by using the higher level language, so it will be the input to an assembler. It will be an input to the assembler. The assembler has to generate an object code for each and every instruction. After that it has to make an object file for the linker loader. How actually it is going to generate an object code? So before here I don't know any address, I have not mentioned the address of the location, for the instructions. So what we can do is for this, so means for writing that program, for every program it is for writing that code program, just we are using different kinds of assembler directives. There are 6 different assembler directives are there. There are 6 types of assembler directives are there. Start, end, right, word, byte, reserve byte, reserve word or reserve byte, and reserve byte. So these are the different, some more assembler directives are there. These are the basic assembler directives which we are using when we are writing that program. That is a start, end, word, byte, and reserve byte, and reserve byte. Assembler directive, it is not a part of mnemonic value. It is not mnemonic. It is not an instruction. It is a directive which directs as an assembler to do something. What actually it is insisting. So means if the assembler directive is word, so it is telling an assembler you have to define a integer variable. So for that whatever the variable just we are giving. Reserve word means it is directing an assembler you have to reserve this much of space for that particular variable, like that. So means start is nothing but start of the program. So means the user can mention the starting address of that program. The user can mention the starting address of that program. Otherwise, if the user has not mentioned, by default the assembler will take the starting address of that program is 0. Either I can mention, otherwise it can take 0. That is the logical address. So whatever the address which is being generated at the assemble time, it is called as logical address. So end, so which is used to tell end of the program. So here in this program just I have not used any kind of start and end. So here if the user want, I can mention that program must be started from the location 1000. Just I can give any value. That's my wish. Right. So if I have not mentioned the starting address in the start assembler directive, what actually it is going to taking is the starting address of this program, it will be taking 0, like that. So means after that I need to mention where actually the program is end. So once the program is end, again the control, it must be point to the first instruction. So here for that first instruction just I have not mentioned any variable name. So just I can give the variable name for that, the label name for that first instruction is first. You can give any name for that one. So that first instruction label name must be mentioned in the operand field. So this is, so means once the program is assembled, so for linking or for loading, again it has to transfer, the control has to be transferred to the starting point of that program. So once it encounters the end assembler directives, means the control has to be pointing to the first instruction. For that we have to mention the label name. So for that just we are giving the label name there. Right. So means end, word and byte. So means for defining the integer, float also just we can use for defining the floating point value. Word, it is for defining the integer constant. It is integer constant. So this is character constant. So this is character constant. Reserve word, it is going to reserved the n number of bytes which are required for that characters. So reserve word, reserve the number of, reserve for number of integer values, reserve byte, it is reserved for character. So these are the basic assembly directives which we are using in that while we are writing that assembly level language program. Assembly directives, it is not part of what, the mnemonic instructions. So here start, end, word, byte, reserve byte and reserve word, reserve byte. So these are the different kinds of assembly directives which we are using for while we are writing that program. So after that, what actually that assembler is going to do to generate an object code or object file for that program. So we will discuss first what we need to do is, first this will be the input to an assembler. So assembler will take this source code as an input. So first what actually it is going to do is, first it is going to read the first instruction. What is that first instruction? Is that the memory start? What is the memory location? 1000. What actually it is going to do is, first it is going to allocating the memory address for all the instructions. So where actually it has been started from 1000. There are different passes, pass 1, pass 2, multi-pass assemblers are there. So we will discuss later during pass 1 what will happen, during pass 2 what will happen. We will take a simple example, just we will explain such kind of things in the later session. So right, so start. So once the assembler encounters this instruction, as of course the program is being started from the memory location 1000. So just this instruction, this is going to be started with the memory location 1000. So here, since this program just have written by using what? By using SIC program. This is the SIC program. So in SIC program, every instruction length is of 3 bytes. So means this instruction length is of 3 bytes, this instruction length is 3 bytes, like that. So means for that, what is the next instruction? It is 1003 plus 3 bytes. Every time it has to be incremented by 3 because the length it is 3. The length of the instruction it is 3 bytes. So means since these are going to be represented in the form of what? Hexadecimal characters. So plus 3 for the next instruction 1006, for the next instruction 1009 plus 3 for the next instruction. For the next instruction plus 3 means 12, it is 100C. Okay. So here subsequently, so the following what data things are there. So just let's take us in a similar way. If there is no gap between such kind of things, what we can write is 1003, 12 plus 3 is nothing but 12 plus 3 is nothing but 15, 15 is nothing but F, 100F, 100F, 100F plus, so here it is what kind of integer type it is? Word. So word, what is the word length? Only one integer is there. For single integer it requires one word. One word is nothing but 3 bytes. So means we need to add 3. 15 plus 3 it is 18. 18 is nothing but 1 2. So here 2 1 0 1, that is 1 0 1 2. So just we have to add plus 3 for this one. So by adding that value for the constant and the reserve byte, we should take care of that one. So here it is going to be incremented by the number of spaces which are being used by that particular constant and reserve space. So what is the next one? String 1. How many bytes are there? 11 bytes. The string it is of 11 bytes. So what is the string length? It is 11. So for the next space we need to add 11 bytes. It has to be, the program counter must be incremented by 11. So means 3 2 1 0. This is 1 0 2 3. So next the 11. Here the string 2, it is a reserve byte. It is a reserve byte. How many bytes it is going to be reserved? 11 bytes. Again it has to be incremented by 11. Again it has to be incremented by 11. So means this is 4 3 0 1 1 0 3 4 1 0 3 4. For at the end no need to calculate that one. So once it encounters the end means it is enough. right. So means this is how actually the assembler is going to assign the address according to that what the address has mentioned by the user. If the user has not mentioned any address in that particular start assembler directive, what actually is going to do is it is going to consider the starting address location for this program from 0. It is been started from 0 itself, 0 0 3 6 9 C F 1 2 3 2 4 2 3 3 4 like this. So this is the thing, it is going to be done by an assembler. Assembler is going to do first, it is going to assigning the address according to that the address what just we have mentioned in the start assembler directive. So after that what actually it is going to do is, so just it is going to what assemble that instruction one by one, means it has to generate an object code for this program one by one. So since it is what SIC program, it is providing only 2 addressing mode, you can see that for this instruction it is direct addressing mode, because in the operands field, in the symbolic field there is no index register. For these 2 index register addressing mode, for this 2 instruction it is direct addressing mode. So for the remaining thing just we have to convert that constant value like that. So in this case what we need to do is, so here first what actually the assembler is going to do is, in the first step it is going to convert mnemonic value to opcode. Its equivalent opcode. It is going to convert the mnemonic code into opcode. What is the mnemonic code? LDX. What is the opcode for the LDX? It is there at the page number 470 in the system software textbook. The LDX, what object code for this means 04. So first it is going to convert that mnemonic value into its equivalent to what opcode, that is the 04. So after that it has to convert the symbolic value into its address. So now this memory location like this, 0 is at the memory location 1000, again the string 1 is at the memory location, where from 1012, from string 2 it is at the memory location 1023, because 11 strings it is already there, the string is already there here, test string. So string 2 it is at the memory location 1023 and 11 it is at the memory location 1034. So this is the memory structure, that is the logical address. So after the symbolic value into its address, since it is direct address, so means 0 where actually it is there, at the memory location 100, where actually the 0 is there, at the memory location 100F. So means it is going to convert the symbolic value into its address. What is the address of 0? It is 100F. So just it is going to write 100F here. So this is an object code for this instruction. So because it is direct addressing mode, in SIC it is very easy to get the object code, but in SIC XC it is not possible like that. For everything just we have to find out the displacement value, so then we have to write the object code. So that takes SIC XC program also for explaining the same, right. So after that LDCH string 1 comma X, so means load character, the load accumulator with a character which is present in string 1 at the memory location 0. Now it is index register value, now it is initialized to 0. So first it is going to convert LDCH, that is the opcode for LDCH, it is 50, 2 hexadecimal digits. So then string 1 comma X. So here the target address we have to consider what actually we need to consider, the string 1 address plus the index register value. So what we need to do is, so here just we have to write the instruction format to get that one. The first 8 bits it is opcode. What is that opcode? It is 50. Just I will write it directly. After that, what is the buffer address? What is the string 1 address? Where actually the string 1 is there at the memory location 1012. So just write like this, 101012. So this is the address. So here since it is an index register, right, so the index register value must be set to as 1. So means after that we need to get that value 5, 0, 8 plus 1 it is 9, 9, 0, 1, 2. So this is an address. It will be changed. So because we are changing the X register value as 1, 509, 012. So for the second also, just we are going to get the same thing. Store character, for the store characters, it is 54, 54. What is the, where actually the string 2 is there? Where actually the string 2 is there? String 2 is at the memory location 10, 1023. 1023, 1023. So means to get this one, since it is index register value, it should be 1 only. So means to get the one, get this one 54. So directly I have written the hexadecimal code here. So 549023. So the object code for this instruction, it is 549023. Right. So after that 1009, 1009, it is direct addressing mode. So where actually the T11 is there, first it is going to convert this mnemonic value into its opcode. TIX, it is 2C. So where actually the 11 is there, at the memory location 1034. Where actually the memory location, it is 1034. What is the next instruction? JLT. JLT is nothing but move CH, move CH. So means where actually JLT, what is the opcode for JLT? It is 38. It is there at the textbook, at the last page, at the page number 470, right? 38, it is the opcode for JLT. So then move CH, where actually the move CH is there? The memory location 1033. 1033. So the next thing, so whatever the remaining things are there, so just we have to convert it, it is equivalent to constant. So what is the word? It is the 0. So 0, just we have to convert 6 hexadecimal digits like that, 0, 0, 0. Right. So after that, what is the next string? It is the test string is there. There is the 11 characters are there. For each character it requires 1 byte. Each character it is required 1 byte. So every character, just we have to represent its ASCII value here. So for representing the ASCII value in hexadecimal digit, again it requires 2 hexadecimal digit. It requires how many hexadecimal digits? 11 into 2, 22 hexadecimal digits which are required for representing these kind of things to convert this test string into hexadecimal digits. So after that, please do remember, for reserve space, we are not going to generate any kind of object code. Only that word and byte for the assigning values for that constant values. So just what we have to do is, so just we have to convert assembly directives constant values, and for the reserve byte and reserve word, we are not going to convert, we are not going to generate any object code for that one. So for reserve byte, it is not going to generate any object code. For the next one, it is 11. What is the word? What is the type? It is integer type. So what is the value which is having 11? So 11, how we can write? 1, 2, 10, 8 plus 2, 10, 10 plus 1, it is 11. So 11, just we are going to write like this. Sorry, 11 is nothing but A is 10, B is 11. So here it is 0, 0, 0, B. So for the end assembler directive also, it is not going to generate any object code. So after generating an object code for each and every instruction, what actually it is going to do is, it is going to combining all those things. So then it is going to making object file. The object file, it is having different kinds of records. So since it is SIC programming, getting object code, it is very easy because it is providing only 2 addressing modes. What is that? That is direct addressing mode and index addressing mode. So hence it is very easy to get what object code for SIC. So I will take the same example for SIC XC programming. How we can calculate what is the drawback of that SIC programming language or SIC machine architecture, how we can overcome the same by using SIC XC by using different kinds of formats. We will discuss the same thing in the next session. So here in this session just I want to conclude. So just we learned what is the main function of an assembler, how actually the assembler is going to convert that source code into object code. So this is only that it is going to converting, it has converted that object code. So the same object after combining all the object codes, then it is going to making an object file for the loader to be loaded into the primary memory. So here just I want to end up this session now. Thank you.